So for our first day of probability, we are going to take a look at some Venn diagrams. So we're going to take a look at this first one on the left first. Of the 100 students, 30 students play badminton, and of those, 16 do both archery and badminton. So if we go down to this Venn diagram, we can fill it out here. So if this was badminton and archery, there are 16 students that do both. And we know that there's 30 students that do badminton. So if this is 16, this must be 14. And we know that there are let's see here. Back up here, and we should say that 38 do archery. My bad, I thought there was something missing there. So if we go back down here, if 38 do archery, that means that there has to be 22 that do archery only. So now we're going to go back up and take a look at these probability questions. A student chosen at random does both archery and badminton. So if we are taking a look at they do both, how many do both? Well, we can look at our Venn diagram. That's 16 out of 100. A student does not do badminton, but does do archery. Well, how many are archery only? Well, there's just 22 of those. So this would be 22 out of 100. How many does either archery or badminton? So either archery or badminton, well, there was the 16 archery only, 22 badminton, and the 14. So if we add those together, we have 52 out of 100. And the last one, a student does archery or does not do badminton. So a student does archery but does not do badminton. So if we look at that again, was it and or does not do badminton. So we have these 22 right here, but there's a whole bunch of other students we haven't accounted for. So if we look at our total here, 16, 26, 30, 40, 52 total, we still have quite a few students that don't do any of these. So there's 48 students out here that aren't in either circle. So we're looking for a student either does archery or does not do badminton. So how many do archery? Well, these 16 do archery as well, but do not do badminton. We would have this 48. So we have 22 plus 16 plus 48, which is 86. So we would have 86 out of 100. So our next one we're going to look at, in a group of 30 students, 17 play computer games, 10 play board games, and 9 play neither. So when you look at this, we don't have that middle number yet. So let's see if this is X. And so we don't know how many play, but how many play computer games was 17. So if this is computer over here, and this is board, this would be 17 minus X. And 10 play board games, so this is 10 minus X. And then out here we got 9 playing neither. Well, let's see, what do we know this has to add up to is 30. So we could write the equation 17 minus X plus 10 minus X plus 9 has to equal 30. So let's see, X minus X, so that'd be 27, 36 minus X has to equal 30. So we know that X has to equal 6. So we could rewrite this stuff now. We know that there's 6 here. 17 minus 6 is 11. 10 minus 6 is 4. So now we can take a look at these probability questions. A student chosen at random from the group plays board games. Well, how many play board games? That's 4 and 6. So that would be 10 out of the 30 play board games. A student plays both board games and computer games. Well, we saw that middle number that we found was 6 out of 30. And then this last one, a student plays board games and not computer games. Well, how many played just those board games but not computer games? That would be those 4 right there. So we would have 4 out of 30. Now we're going to take a look at a little notation here. So, whoops. Let's see. I'm going to add a new page. So, we're going to take a look at some notation. So let's go back to that archery and board game. If A equals archery, or badminton, excuse me, and B equals badminton, if we saw the notation A intersection B,
Happy Friday, Oriole staff. Professional development
what that
is
means
beginning
is
now
the
in the
intersection
Media
of
Center
A
classroom.
and B
Have a great day.
of the students that do both. So this means the intersection right there. So if we go back to our badminton question here, let's see. If we wanted to know the intersection, there was 16 out of the 100. So our intersection would be 16 out of 100 students. You will also see a notation. Well, actually, why don't we just go back up and look at these problems here. A student does both archery and badminton. So the way that we would look at this is the probability of A intersection B. So A and B right there. A student does not do badminton, but does do archery. So we want the probability that they do not do badminton. So that is known as the complement. So it's with a little apostrophe. So does not do badminton and does archery would be written like that. The next one, a student does either archery or. So our key word here is or. So the way that that is written is the probability of B union with a U or archery. So that or is with that U letter. A student does either archery or does not do badminton. So the probability of archery or not badminton. So I guess the key things that you need to remember in this notation here, the upside down U equals intersect. I think of that as like the and. The U means or. And if you see that prime, that's the complement, not B, otherwise known as the complement. All right, so we're going to take a look at a couple probability questions now and see what you guys remember from previous classes here. So, let's see. A card is drawn from an ordinary pack of playing cards. Find the probability that a card is a heart or a king. Well, so if we were to look at this, how many hearts are in a deck are 13 out of 52. How many kings are in a deck is 4 out of 52. So normally add those, but we have to subtract the overlap here. And there is an overlap of a king that is a heart. So we have to subtract that overlap. So if we subtract this, we have 16 out of 52. Our notation for this is for any two events A and B, we can say the probability of A or B happening, so a king or a king, a heart or a king is the probability of A, plus the probability of B, but we have to subtract their intersection. So we have to subtract the probability of A and B. So let's see, the next one that we are going to take a look at here. In a certain road, 1/3 of the houses have no newspaper delivered. If 1/4 have a national paper delivered and 3/5 have a local paper delivered, what is the probability that a house chosen at random has both? So let's see here. If we were to draw a Venn diagram here, we know that 1/3 is sitting out here, but we don't know what's in the middle. So let's say this is local and this is national. So that would be X. 1/4 have the national paper delivered. So this would be 1/4 minus X. 3/5 have the local paper delivered. So this would be 3/5 minus X. And when we add all of these, it should equal 1. So 3/5 minus X plus X plus 1/4 minus X plus 1/3. Well, our total has to be 1. So let's see, we need a common denominator here to add these fractions. We could do 60, so times 12. So 36 out of 60 plus 15 out of 60 minus X plus 20 out of 60 equals 1. So 36, 46, 56, 66, 71 out of 60 minus X equals, I'm going to write that as 60 out of 60. So X has to be 11/60. And this, let's take a look at this next one here. A box contains board pens of various colors. A teacher picks a pen out at random. The probability of drawing a red pen is 1/5, and the probability of drawing a green pen is 3/7. What is the probability that it is neither red nor green? So if we take a look at these, we can add these together. So here's our red. So this would be red or green. So our common denominator, 7 out of 35 plus 15 out of 35. We add those together, we have 22 out of 35. Well, how many would not be those? So that would be 13 out of 35. So if we look at what this question is asking, it's the probability of not red, so we could say the complement, or not green.